Today we're starting something totally new. In Unit 3, which is where we're at now, Unit 3, we're switching gears kind of again, and this is where statistics and a lot of what we're doing becomes really relevant, and this is stuff that's used all the time for statistical analysis and making predictions. Okay, so before what we were doing, in Units 1 and 2, we had populations we knew about, and we wanted to find the probability of randomly selecting an item, a person, or a bunny, etc., in a specific region. Okay, and so I have this example here. We were trying to find the weight, or rather I was told, the weight of bunnies is normally distributed with a mean of 6.52 pounds and standard deviations of 1.3 pounds. And this information right here, this is to do with the population. Of the entire population of bunnies, this is their average weight and their standard deviation. So all the bunnies fit into this normal curve here, all the bunnies in the entire world. And we would want to find the probability of randomly choosing a bunny that weighs 4 pounds or less. Okay, so what we're looking at is we're trying to find the probability that something's in this region here. So we randomly pick a bunny in this region here. And we know that probability equals area. So we're finding the probability that X is less than or equal to 4. We put this on our calculator, normal CDF, and remember the C stands for cumulative distribution. Okay, and we put in the min, the max, the mean, and the standard deviation, and we get out some value. Okay, so we know what the population is, and that's a huge distinction because in Unit 3, we don't know what the population is, and we're trying to extrapolate some information. Okay, so in Lesson 18, and really in all of Unit 2, or excuse me, in Unit 3. Okay, but I'm going to start out talking about just Lesson 18 and what we're going to do today. We don't know anything about the population, but we're trying to learn something. Okay, so the only thing we can do is we can take a sample and use that sample to make an educated guess about the population. Okay, so really we're kind of extrapolating information from the sample. Okay, and if you remember from way back when we were doing linear correlation, extrapolate means that you have a set of data and you're trying to find something based outside of that set of data versus interpolation, which is when you're within that set of data. So we're trying to extrapolate from the sample, but samples vary, and this is a huge thing to keep in mind. Okay, so we can never be 100% sure, but we can be 90% sure, 95% sure, or 99% sure. Either way, we're going to be wrong 10% of the time, 5% of the time, or 1% of the time. So that's what this means right here. However sure we want to be, and in each of these situations, I will tell you how sure we want to be. This sureness tells us that we're only going to be right this amount of time. So if we're right 90% of the time, we're wrong 10% of the time. If we're right 99% of the time, we're wrong 1% of the time. Okay, so being 90% sure of something is often a little bit too narrow. 90% is something that's actually used a lot in like polling and that kind of thing. Okay, but the population, the more sure we want to be, the wider window we're going to get about the population. Okay, so if we're 90% sure about something, this population window we get, which that's just a term I made up, okay? It's not a technical term or anything. But the window we're looking through is going to be pretty small. But if we're 99% sure, the window we're looking through is going to be really wide. So we often choose kind of this sweet spot of 95%. Statisticians, this is kind of the gold standard of 95%, depending on what you're trying to do, but it's kind of a default unless you're in a certain circumstance and you negotiate doing 90 or 99, and it could be 98, it could be 97, okay, but just know we just pick 95 most of the time, okay? And there's no reason we couldn't pick other numbers from this, okay? These tend to be the standard ones we pick. Okay, so here's an example of that same bunny thing, okay, but we don't know in this example the population. We know nothing about the population, but we have a sample of 30 bunnies, and that sample had an average weight of 8 pounds with a standard deviation of 2 pounds. And remember, this standard deviation is from the sample. And so that's why we call it the standard error, okay, and of the 2 pounds, right? So we want to find the range of weights for the population of bunnies with a 95% confidence, okay? Now we saw above, we know what the average weight of all the bunnies is, okay? So you might look at this and go, yeah, that we got a pretty heavy sample, right? They're heavier than the most of the population, but for these purposes, we don't know that. Okay, so we're just gonna roll with this and see, well, what does that tell us about our population? Okay, so what we do is we find what's called this confidence interval, and it's gonna look like this. And those of you that are remembering, if you ever learned interval notation when you took algebra, or if you took algebra, this is interval notation. This is telling us that the population is in between 8.7 and 7.3 pounds. Okay, so in English, what this says is we're 95% confident that the average bunny is between 7.3 and 8.7 pounds. There we go. Fix my typos. Okay, so this is what we're doing in lesson 18. Okay, we're coming up with a range for the population. And you would have seen this really recently with polling. Okay, yes, the election has happened, okay, but I'm still going to talk about these polling because this drove me nuts during the election. Okay, so you'd see a poll or on the news, especially like the couple weeks right before the election. I would see some polling and it would say Biden had 46% of the vote and Trump had 44% of the vote. And the newscaster would say, oh, look, Biden's winning. Biden's winning. But here's the thing. That's not necessarily true. Every poll that is really reputable, any reputable poll will give you more than just this. Because without this, this information here is based on a sample, right? And this sample is intended to be a range reflective of the entire nation, right? And even though that sample might have had 30,000 people in it, we have like 150 million people in our country that are voters, likely voters, right? So even our sample as large as 30,000 people is still a small sample. So without knowing what's called the margin of error, this sample is useless. If you look at this margin of error for sampling is typically between 1 and 3%. Okay, so let's say for this one, it's 2%, just for the sake of argument. Okay, every time you see a poll like this, you should always be looking for the margin of error. And the reason why is because the margin of error is where we get that interval that we're extrapolating. Okay, and so what I want to know is approximately how many people in the country would be voting for Biden. And if we use this margin of error, this means I could add 2% or I could subtract 2%. Okay, because every poll needs to be adjusted. Okay, if we're going to extrapolate to the population. And how we find this margin of error, our calculator is going to be doing this for us. Okay, but just know it's an easy formula. We could do it pretty easily. Okay, so if I add 2%, this is going to give me 48%. If I subtract 2%, that's going to be 44%. So that means approximately 48 to 44% of voters were for Biden in this poll. All right, so this right here, this is my confidence interval. Now we can do the same thing with the likely Trump voters. But again, this margin of error is 2%, so I could add 2% of this and subtract 2% of this. So plus 2% is 46%. minus 2% is 42%. So I could say approximately 42 to 46% of voters are for Trump. So again, I have a second confidence interval there. Okay, do you see what the problem is? Is one of these actually winning? Could you say that Biden or Trump is actually winning if this 44 to 40, excuse me, I wrote that in the wrong order, didn't I? 44 to 48% are for Biden and 42 to 46 are for Trump? Can you actually legitimately and responsibly say that Biden is ahead in this poll? Statistically speaking, this is what we call a statistical tie. And it's a statistical tie because if we look at this 44 to 48 and we look at 42 versus 46, do you see this region right here? That's a tie. Both of them have the range 44 to 46. That's the idea between what we're doing here. This is all going to be done on our calculator. We could easily do the math, though. It truly is not hard. But, you know, we paid $100 for these calculators. Let's use them. That's my feeling. So just when you think about what this confidence interval is that we're doing, just keep in mind it's this type of thing. This polling, using a poll or using a sample to extrapolate what the entire population is going to say or do. We're going away from the second VARS because we're not doing distributions anymore. Second VARS was for Unit 2. Now we're going back to the stats. So we're really ending the semester where we started this semester in the calculator using L1, using L2. That's where we're going with these. Let's go on to the lesson then. What we're starting with example 1 is also a poll. Okay, and what we did here is, you know, we took that p hat, let me go back up here and say these values that we got for our original out of our sample, this is a p hat. Remember, p hat is what we refer to as the sample proportion, and p, straight up p, is the population proportion. We put a hat on it to denote that it's a sample. You were asked to do example 1. Now in this one, I'm not going to really do example 1. You can do that on your own. I do want to make sure you know that, you know, some of the videos you'll be watching will be talking about the margin of error, and it's really easy to figure out the margin of error given the range, but we're not focusing on that, okay? Let's talk about what a confidence interval is. And really, I've just explained this to you, but in more formal definitions, it's a way to measure how well one sample represents the entire population. That sample statistic that we denote with p hat, we call that the point estimate. And we call that the point estimate because if I go back up here, let's just look at Trump because that's the lower one. And I want to look back at this math here that I just did. If I take a number line, I put 44 in the middle, that's my p hat, and then I'm taking this margin of error, and I'm taking the margin of error and I'm adding to and I'm subtracting to. Okay, and that's how I'm getting my other values. That's how I get to the 46 and the 42%. That's why we call this middle one the point estimate, because we're using that to go up and down. You recognize this hopefully because that's what we did with the normal curve. You had a mean and then you use the standard deviation to go above and below. It's the same concept, but this is how we get our interval. Based on this one poll, we can be 95% confident of all the likely voters in the US, about 42 to 46 of the population was going to vote for Trump. Okay, and again, I just made up these numbers, folks, to illustrate what information you've been seeing. So let's go back to here. We like to translate the confidence interval we find with the sentence here that we are 95% confident that between blank percent and blank and blank percent of the population you're studying does something. Okay, so for our example, we could say we are 95% confident that between, let's go back up here, sorry. We are 95% confident that between 42 and 46% of all voters in the US are going to vote for Trump. Okay, that's how we would translate that. Okay, so what we need to know in order to write this interpretation is we need to understand the population we're studying, and we need to understand what's called the population parameter. And that's really the thing that you're interested specifically, right? So in our last example, the population is all voters in the US. So all voters in the US is the population. and vote for Trump is the parameter, or for the early, or we could say vote for Biden if we're going to put Biden's numbers in there. And this part here, starting on page 2, this is all what's actually happening. The math that's happening and the computations that are happening behind the scenes. As I said, it is not hard. We could totally do it by hand, but we're not focusing on that in this class. But I do want to make sure that you see here, this is the actual empirical rule. Remember I told you that approximately 68% of data was within 2 standard deviations? Well, it's actually 68.2%. You can look at this to get the real values, or actually rounding, my bad, 68.3%, and not 95, 95.4, but this 99.7 is actually accurate. I want to point this out. Example 2 is doing all of these computations by hand, totally doable. You could do it. It's not hard. Okay, we're just not going to focus on that. I want to focus on us doing the calculations in our calculator. So you can do this on your own. It's important to understand where these values are coming from. The 2 types of confidence intervals we're going to do. The first one is for finding the proportion for the population. So that's like what we just did. What proportion of the population is likely to vote for Trump? The second one is to find the average, or the mean, of the population. So that would be based on our sample of bunnies. What's the average weight of the population of all the bunnies based on this one sample? Your job from today and for the rest of the semester and all of these coming up lessons, that's going to be the same. We're going to do one topic, but we're going to do that one topic 2 different ways. Once for means and once for proportions. So you've got to be conscious and be careful to always be reading and looking for, is it proportions or is it means? So always keep an eye on that. And when I'm doing my work, I always circle the mean or the proportion to just help me remember what it is I'm finding, because how we put it in our calculator and what function we use in our calculator is going to be different based on if it's proportions or if it's means. We're going to learn a lot of calculator functions. In every single one of these lessons, there's 2 calculator functions. So you're going to have to keep this straight. So I'm going to keep telling you some tricks that you could use to help you sort out which function you should be using. Okay, so for this one, we're doing an interval as in confidence interval. So just remember, it's INT for the confidence interval. And you see here this prop, this means proportion. And the 1 means we only have 1 sample. Later in the semester, in later lessons, we're going to have more than 1 sample. So those little keys, just recognizing that, can be very helpful for you. But let's do example 3. Here's our calculator function. We have a sample of 188 students in a large dormitory cafeteria. Showed that 66 chose the vegetarian option for their meal plan. Let P represent the proportion of all students selecting the vegetarian option as their meal plan. So this right here, that's the population. Actually, I misspoke. That's not the population. All students is the population. And then this selecting the vegetarian option as their meal plan is the thing that we're interested in the population doing. Refer to that as the parameter. Okay, so we have a random sample. We want to find the 95% confidence interval for the proportion. And so you see my calculator function has proportion. We're finding a confidence interval, so we're using INT. So we have a random sample of 188 students. So that's our N, because our sample was 188. Showed that 66 chose the veggie option. So this is our successes. Remember, that means X equals 66. Okay, so we're going to put this in our calculator. And all we're going to need to know is these 3 things, and our calculator will spit out the confidence interval for us. Okay, the confidence level is 0.95 because I'm told 95%. X is 66 and N is 188. Back in the stat button again, so we're going to just click stat. Edit, that's where we get to the lists, which are going to come up in the next lesson. Arrow over to test, and then we're going to find A, which usually is up arrow is faster. And there we are, 1 proportion Z interval. That's what that stands for, 1 prop Z int. Stands for 1 proportion Z interval. Press enter, and then enter in our X and N. Make sure to check the confidence level, okay? Make sure there's a decimal there as well, okay? You'll get an error if you don't put the decimal there. Okay, so X is 188, N is 66. Do be careful too. I get messed up a lot because I often think of this as a fraction and I tend to put 66 first and then 188 and then I get an error, okay, because the order is wrong. The X should always be bigger. Okay, then we're going to press calculator. Let's try that one more time. I did see, remember how I said I often put them in backwards? I literally just did that. 66, remember I told you I do it wrong a lot and I get errors? That was the exact error I was talking about. Okay, sorry about that. So X is the number of successes, N is the number of people in your sample one of those days. That was a good example of what happens when you get them backwards. Okay, there we are. All right, so here we have P hat, so it figured out that sample proportion for us. This is 66 divided by 188 is a 0.35, but here is our interval. So then interpret that interval. Think about what that would mean. Okay, so I've got this here. So remember, these are percentages, right? So I can translate those. This means 28.3% to 41.9%. So what that means is we are 95% confident. Everything that's underlined here means it's going to change as your problem changes. Okay, so we're going to write, we are 95% confident that between 28.3% and 41.9% of who? College students do what? Select the vegetarian plan, or will select the vegetarian plan. Okay, so this is something that you might do if you were the cafeteria chef. Vegetarian options require a different menu set, require a different amount of food, and you need to know how much to buy. Okay, hopefully you think that's pretty straightforward. The hard thing is you want to figure out, is it a proportion or is it a mean? And then just pull out the information to put in your calculator. You can do this one on your own. So we're going to do the confidence interval for population means. It's a little bit different, like I'd said. Okay, notice here, the test we're using is different. The test we're doing is different because the standard error calculations, remember, are different. The standard error for the proportions is different from the standard error for means. For proportions, it's the square root of p minus 1 times 1 minus p all over n. You might remember that, an earlier lesson. But like I said, we don't have to calculate that, so that's nice. All right, but that's the crux of why we have different calculator functions, because the computations are different. So now we're doing an interval that stands for confidence interval. Okay, and now because we have averages, even the data we're given might be different. If we're doing proportions, that proportion is, what percentage of the population was brown bunnies, or what percentage of our sample was brown bunnies, what percentage of the people were going to vote for Trump, what percentage of the people were going to vote for Biden. You don't have raw data. You don't have individual level raw data. It's just you ask them the question and you calculate the averages. But if we're finding the means, we have different individual level data. Okay, so in example 5, we have adult patients being treated for severe muscle spasms called tetany. I don't know. Maybe some of you know how to pronounce that. So this condition is associated with an average total level of calcium below 6 milligrams per deciliter. Okay, we just have to worry really about the 6 for now. Okay, recently the patient's total calcium test gave all the following readings. So we've got all these different patients' calcium readings. And so we have individual level data. So what we need to do is we need to put this all into L1. And then we can calculate it. Sometimes we'll be given the summary statistics, the sample mean and the sample standard deviation. Sometimes we're given the raw data. We have 2 different options here. Now we're going to live in the stat button for the rest of this unit. Everything's under stat. Remember stat edit? I'm sure you were really good at this at the beginning of the semester, but you've probably forgotten a lot. I have data here that I need to clear, so I'm going to arrow up. I just need L1. I'm going to arrow to L1, press clear. Notice that cleared the list here, but not here. I have to press enter, and that clears all of list 1. Okay, so now enter in that data. And remember this number right here after the L1, that 10 means I have 10 pieces of data entered here. So I'm going to go back to my list and double check that I have 10 items on my list to make sure I didn't miss anything. Then what we're going to do is we're going to go back to stat and we're going to do the test, find the confidence interval. Arrow over to tests, and then it's 8T interval. If you know which one it is, you can actually just press the number 8. You don't have to arrow down to number 8. Okay, now you see here my input, I've got two different options. Data is for when we have that raw data of a list. Notice the very first thing it asks us is what list we're going to use for our data. Okay, that's how you know you want the data one. That's how I remember which one is which. Is the one that asked me for the list means I better have put some data in a list. Versus stats, it's asking me for the sample mean and the sample standard deviation and how many things were in my sample. So this is the summary statistics. Okay, I don't have that. I have the raw data. So I go back to data, press enter. L1, yes, I put my data in L1. Always double check that. Frequency, leave that alone. That's a more complicated thing than we're doing in this class. Confidence level, it's listed at number 20. Normally I would put it up with the description. I apologize for that. So it is a 0.95. We're going to go down to calculate and press enter. And there we have our confidence interval. Now notice these aren't decimals. These are big numbers because remember now they're averages, they're not percentages. Okay, so the average of my sample was 9.95. The sample error was 1.02, 10 items in my list. So this is the average for the population. Here we can just do 2 decimal places. Okay, I've got this here. I just got too excited about the calculator. Let's go back to 19. Okay, what's the population and what is the parameter? Remember, the population is everybody you're interested. The parameter is the thing you specifically interested in about that population. Several months, an adult population has been treated for tetany. Okay, recently patients' total calcium tests gave the following readings. What we need and what's helpful is down in question 20. And I apologize, I never realized that. We're asked to find a 95% confidence interval for the population mean of total calcium in the patient's blood. This is our parameter. Our population is adult patients being treated for tetany. Tetany? Does anybody know? So the third semester I've taught this. You'd think I would have looked it up, but no, I haven't.
Katrina, doesn't it look like it looks like they're just looking at one patient, not a
yeah,
population.
That's just a typo on my part.
I mean,
that
got
is
it.
what
Okay,
it says.
thank you.
You're right.
Okay.
That's a mistake.
Okay,
Thank you for pointing that out. You're absolutely correct, though. So the population is adults being treated for tetany, and the parameter, I apologize, it's a little bit smushed, the total calcium in their blood. So again, population is who we're interested in. Parameter is what specifically about them we're interested in. We interpret the interval we found. Now I'm jumping down to 21. Sorry, I realize this example could have been better set up, so I apologize. I'm kind of having to jump around all over the place. Okay, so we're going to interpret the interval. What we found here tells us the average levels of calcium in the population. Remember, we're extrapolating. We would say we are 95% confident that, now for the mean, the phrasing is going to change a little bit. So we're going to say patients being treated for tetany, here's my population, have an average of 9.22 and 10.68 milligrams per deciliter of total calcium in their blood. So this is the parameter. I apologize, I don't have a shell wording for this, but you just got to make sure that you have the population in there somewhere, you have the parameter in there somewhere, and you have the average values that you found. And this is where you're lucky. Your tests are going to be drop down, multiple choice. Okay, so you don't have to worry too terribly much about writing this. If we were in person and I was giving you a written test, you would absolutely need to be able to write this yourself. But for you folks, you don't have to worry about that. You're kind of lucky that way, because this is the part that my students have struggled with the most in the past. In a lot of ways, I think students feel this is the hardest part of the question, is writing this interpretation. Let's do another example. Take a look at example 6 and see if you can pull out the population and the parameter, and make sure to notice, is it means or proportions that you're looking for? So we have 20 randomly selected managers were found to spend a mean time of 2.4 hours per day on paperwork. The standard deviation of the sample was 130 hours. Managers 20, and 1.3. So notice how I went through and I just underlined all the important information. All the numbers are indicated. A person, a subject is also indicated. So here I know N is 20. I know my mean X, which is X bar, is 2.4. And my sample standard deviation, which is SX, is 1.3. Or we could say, technically it's sigma of X bar, okay, but our calculator uses this. Our calculator uses S of X because it doesn't have the ability to do the Greek symbols, okay, but just know this is technical, this is our calculator. So we want to find a 90% confidence interval for the population. See here it says 4. That's a hint that what's happening next is telling you both the population and the sample proportion. The population mean time spent on paperwork. Okay, well, and so what's the population here? Well, that's where this came in, right? Really, the sample is talking about managers, which tells us our population is managers. So I'm going to put this over here. The mean time spent on paperwork, that right there is telling you the sample parameter, or really just the parameter. For me, I find it's easier to think about it in terms of average. The parameter is the average time spent on paperwork, and the average as a mean. Okay, we're going to go to Stat, arrow over to Calc, and down to 8, or you could just press the number 8 and press Enter. Okay, so we're still doing t-interval. Now again, so data is asking for L1. We're not given raw data, so I'm going to arrow over to Stats, Enter, and now here's where I'm going to put in the sample information. So our sample mean, 2.4 hours per week on paperwork, sample standard deviation of 1.3, and how many people were in our sample? That was 20. Confidence level, double check. Yep, that's 0.9, that's 95%, so 0.95. Press calculate, and there's our interval. And see, this is how we can double check the information. You see it spat out exactly what we put in. It finds us regardless of if you put in raw data or if you put in the statistics. So I'm going to write that down. 1.79, just do 2 decimal places. That's when it's a percentage that we really need those 3 decimals. And we could even do 1 decimal place here. Okay, did anyone not get that from their calculator? What we want to do is interpret the interval. So try your hand at doing the interpretation. I'll put a shell there. And when you can skip number 24, we're not going to find the margin of error. Okay, remember we are blank % confident that the population does something. So there's a few different ways you could interpret this one. The means, I'll be honest, the interpretation of the means is kind of the most difficult one of them all, because our want is to have a sentence that's grammatically correct, which kind of makes it more difficult to have a standard protocol way to write a sentence. Okay, so we are 95% confident that managers spend an average, and I always write it like this: spend an average, and then in parentheses I put mean to indicate what average I'm talking about, of 1.8 to 3 hours on paperwork, because that's what this means, time spent on paperwork. And you know that's what it is, because if you go back up to reread that example, there's a lot of clues in this example for what it is we're looking for. Okay, so reread this, and it says 20 randomly selected managers. That's telling you the population, because that's who was randomly selected. Found to spend a mean time of 2.5 hours per day on paperwork. Time on paperwork. That's the parameter that we're looking for. What is it that managers do that we're interested in? We're interested in how much time they spend on paperwork. Like I said, it's not an easy or intuitive topic per se, but it is something that you know and that you've been doing for a while. So let's go on to example 7. Here's what I was saying, that with each lesson, we're going to have 2 calculator things. We had 2 calculator options already, but this is kind of the way you can think about or determine which one to use. For each problem, we're going to find the interval using our calculator, interpret the error, and we're actually not doing the margin of error, so you don't have to worry about that. Right now, we're just focusing on finding and interpreting the confidence interval. But you need to know which calculator function to use. These are all under stats and tests, so you need to determine, first of all, is it a proportion or is it a mean? If it's a proportion, it will say proportion. And that tells you want to use one prop z int. And again, prop stands for proportion. Interval stands for confidence interval. The z, there's something to be said for the z too, but I'm going to hold off on showing you that. I think you'll notice when we use z and t. For now, just think about these. Prop and interval. If it's means, it will say average or mean, and you may be given raw data. Okay, if you're given raw data, you're definitely going to be looking for means. And notice again, this is a t, and it's an interval. So do make sure to check these because there are a lot of other options that may look similar to this on your calculator, but at least knowing if you're finding a confidence interval, you're looking for something that says int or interval, and that narrows it down from like 20 options to 4 options, okay? And 1 because there's only 1 sample. And that's good to keep in mind because later on we're going to be having 2 samples. Okay, that's in 21 though. Okay, so for each of these, oh, I did a typo. I never finished the sentence. In all of these, I'm asking you to find the confidence interval, but let's just, for the next couple minutes, let's not actually find the confidence interval. What I would like you to do is find the population, find the parameter, and determine which function to use. Which calculator function. Okay, and if it's t-interval, you're going to need to decide, are you using the data option or the stat option? Just in case it helps you, means and t's are always going to go together for these functions. Of all of these calculator functions we're going to be using over the next 4 lessons, proportions go with z, means with t's. All right, so let's look at the answers here. First, we'll find the population, will be pink. Parameter, we can make green. And the calculator function we'll write in blue. 25, a random sample of 60 female members of a health club. I'm also, while I'm going to underline this information I see that's important. 60 females members of health club in LA show that they spend an average of 4 hours per week doing physical exercise with a sample standard deviation of 0.75 hours. Find a 99% confidence interval for the population mean. The population mean, that tells us the calculator function right here. This is going to be 8t interval. The population is it the female members of the health club or is it doing the physical exercise? Well, here's a clue. Right here, 60 female members of the health club. That's why, that's why we have those 60 female members. We chose those 60 because they are our population. The sample comes from the population. So the population is not the 60 though, just the female members of the health club. That's who we're interested in, female members. And what is it we want to know about those female members? Well, we want to know how many hours per week are they doing physical exercise? Okay, let's go on to 26. All right, well, while we're here, I'll just tell you, actually, that here we have x bar is 4, and s of x is 0.75, n equals 60, just to make sure that you're all clear what to put in your calculator. Okay, 26. A survey from 39 community college students. 27 said they had a job. Find the 95% confidence interval for the proportion of community college students who have a job. Right here, too, proportion of community college students. And look at that, 39 community college students. And we're looking at how many of them said they had a job. And then you're asked to find the community college students who have a job. Okay, you see how that shows up twice, the population versus the parameter. So here's the population, and here's what it is we're interested in. Okay, now what do we want to find? For the proportion, we're finding the proportion, which tells us we're using the 1 prop z interval. N is 39, and x is 27. If you don't have questions, then have a great afternoon.